In this video lecture, we're going to start taking a look at the details and basic structure of Java classes, including the one we're going to start to design in stages. Okay, let's get started. Once again, even though we've already seen this structure, this is the fairly general layout and structure of some Java source code file, and this is the general pattern we'll use to begin developing our own classes. While this order is by no means set in stone, generally speaking, you're going to find that the instance variables of a class appear first, followed by its constructor methods. As a simplification, for our purposes, we'll say that the general types of methods found in the class are its constructors, its accessors and mutators, all its public utility methods, and finally any private internal use only methods. We'll use this as the roadmap for the class we're about to describe. Here's the intended API for the Java class we're about to start implementing. This is a class called person, and it hypothetically describes a person in terms of 6 general instance variables: their first and last names, which are strings, their birth date, which is a nested CS12 date object, their biological gender, which is a char, and their height and weight, which are doubles. And notice that we're going SI here by saying the height is in meters and the weight is in kilograms. We're making the modeling assumption that any person can be generically described by these 6 attributes. This API is one that I made up, so like CS12 date, you won't find this in the Java API. This API is central to what we'll be doing in the coming lecture materials, so take a moment now to pause and look this over. You'll also find this in PDF form for reference in the lecture materials. Once again, a class in Java typically consists of a small handful of instance variables together with a large body of methods which can operate upon that instance data. Here we have 3 overloaded constructor methods followed by a whole slew of color-coded but grouped methods. This order and color coding does mean something to us, so let's take a look at that next. We're going to build up the person class in stages in roughly the order shown in its API. Here's the color coding legend we'll use to group related methods and help us to make sense of all the details. The display methods, toString and print, are shown in yellow. These are the methods which give us internal visibility into the state of our person objects. We need these to inspect and test our class as we gradually build it up. If you recall from using these for CS12 date, toString is a Java standard method which gives us a one-line string version of an object, while print is a non-standard one which gives us comparable information but in a more detailed multi-line format. The accessors and mutators are shown in green. These are the get and set methods which allow us to retrieve or manipulate individual instance variables, and there will be one such pair for each private instance variable. These public methods will provide us the only access to the private data. The equals equivalence method is shown in pink, and this one checks the field-by-field equality of 2 person objects. The derived data accessors are shown in purple. We haven't talked about this idea yet, but we're going to make the design assumption that there can be 3 additional data quantities: age, IQ, and body mass index, that can be calculated or derived from the basic 6 instance variables. Since we can't independently set these values without affecting the underlying instance variables, there will be accessors only for such methods. Finally, the utility methods are shown in light brown. Many Java classes will have some additional class-specific actions, and in our case, we'll simply assume for now that objects of our person class can eat and exercise, which will affect the weight instance variable in some TBD manner. The person API shown on a prior slide may look lengthy and a bit daunting at first. However, I want to introduce you to a systematic incremental development approach and thought process that we'll follow to build up the person class from scratch in stages. You can also find this roadmap in the current lecture materials as a PDF file. Here on the left is the incremental development paradigm that we'll follow. Starting from an absolutely empty file, we're going to build up the person class from scratch in stages. At each step of the way, we're going to add a few more capabilities to our person class, and at each stage we're going to snapshot our changes into some incremental software waypoints. I'm going to demonstrate this process over the coming lecture videos as we build up the person class. Then I'm going to require you to use the same process in creating your own new class in the coming program assignments. And there's a good reason for this. One of the biggest problems I've seen over and over again in past semesters is students trying to write entire classes from top to bottom in one big gulp without any testing. Or equally badly, I've seen students grabbing a hold of some existing class such as this one, and by a series of find and replace edits, try to transform it into whatever they're trying to create. Both approaches tend to result in miserable failure, with scores of compiler errors and hundreds of lines of code which they really don't understand, with a deadline looming and the ensuing panic. I want to show you what in my experience is a much better way, one that involves a better thought process. Incremental development such as we'll demonstrate may feel slower and more plodding, but over the long haul I can almost guarantee it will save you time and prevent frustration, because you will have fewer errors to contend with. And you just got to trust me on this. The big idea will be to get something simple to work first, then keep adding to it in small, logical stages. This is an approach to software development that will make you better, faster, and more efficient as you gain confidence in it. Before going too much farther, let's discuss how we might go about classifying all the methods we'll be creating for our new person class. In programming or database development, you might come across the acronym CRUD, which is short for Create, Read, Update, Delete. For our purposes, this simply represents 4 generalized buckets into which we might sort all the methods that we'll be writing for our new class. As a reminder, here again is the color coding legend for all our API methods, and all of these will fall into one of these 4 buckets on the right. Create refers to creating new data or information. For us, we'll be creating several overloaded constructors, which we'll use to instantiate new person objects. Read refers to the capability of viewing existing information without altering it. For us, this will consist of our display methods such as toString or print, our accessor or get methods, of which there will be 1 for each instance variable, our equivalence equals method, which compares instance data and returns a result, and our derived data accessors, which will obtain for us certain data derived from base instance variables. Update refers to the capability of altering existing information. For us, this will encompass our mutator or set methods, of which there will be at least 1 for each instance variable, and our utility methods, which allow our person objects to do things, but in the course of doing so, will also alter the values of 1 or more instance variables. And finally, delete would refer to the capability of removing existing information, but it's going to be not applicable for our purposes. So we'll begin setting up our new person class from scratch by creating this generic pseudocode outline for its intended API. The nice thing about this outline is that it's pretty generic for any new class, and this should also be the starting point for the new class you're going to create in your program assignment. For your class, all you need to do is substitute the name of your class on the first line. And if there are any sections which you don't need, simply take them out. Starting from a solid code outline like this, we can gradually flesh the code out in stages, as we'll be doing. Note that although this code is compilable, it's also not executable because there is no required main method in here. That's okay, and it's by design. Up to now, most of your programs have involved mostly sequential execution of one standalone main method. Now we're starting to build a software component which is intended to be used by some outside client code. But we'll see how to test this fairly soon though. A couple things to point out in terms of good practices and good conventions. Note the liberal use of whitespace in this pseudocode, and also the horizontal separator bars. We're going to be creating a whole lot of methods in this class, and this is a nice way of visually organizing them. By standard good Java coding convention, class names always begin with a capital letter, are noun-based, and use the typical camel case naming, except that now with a leading capital. Finally, class names are almost always public, because the whole purpose of writing one is for it to be seen and used by the outside world. To finish up, please take a moment now to view the demo video for personphase1.java, where we'll demonstrate creation of this opening pseudocode outline for our person class, along with some additional things you'll want to be aware of. Okay, that's it for this video. In the next step, we'll begin adding some data to this outline.